In this video session, we are going to cover what exactly is distributed application, high-level architecture of how the earlier technologies like RMI, CORBA, DECOM worked, so that we can understand what exactly was the problem in these technologies for the evolution of web services. And then we are going to discuss what is a web service, where exactly SOAP, Simple Object Access Protocol, fits into it, how to build a web service application and a client application. Then there are certain extension topics like pass by value, pass by reference, working with SOAP headers, and asynchronous call, working with attributes, right? And then security in web services. These are the additional topics we are going to work with. So first, what exactly is distributed application? See, in a network, many computers are connected to each other. Now, when we develop a simple Windows-based application, we get an exe and we execute that exe to run on one machine. And that exe then would be utilizing the resources of only that particular machine and not any other machine. But certain reasons we would like to spread our application over over other machines on the network. That is, we are making our application distributed across the network. There will be one server application running on one machine, providing the service, providing the functionality, providing, I would say, the business functionality, also referred as a business component. So a business component, when running on one machine, can be used by various other applications which are running on the network for different business purposes. So basically it means like this: on one machine I have a business component running, providing some business functionality, and the clients for it are running on the network on other machines. Hence we are trying to use complete network for the functionality we want to execute. For the application, the enterprise application we are trying to develop, we are making use of the complete network. So in this communication we have a server process and we have a client process. So here we have got an actual object which is actually providing the functionality for others. See, basically let me tell you now what could be the problems when we have distributed computing in place. First, server is running in a server process. The server object is running in a server process, and client, the consumer of that object, is running in a client process which is different. That means they by themselves are actually two different applications. So if a client has to communicate with the actual object, it would need to do an inter-process communication. It cannot directly invoke the functionality, the client cannot directly invoke the functionality of the actual object, bypassing the process boundaries. This is one major problem. And not only that, if client has some data in the client process which has to be passed as argument to the methods which are there in actual object. Say for example, now in actual object, imagine I have a method add which is taking one integer parameter and another integer parameter. Now if a client has to invoke this method from this object, it needs to do two things. One is the client will have to get a reference to the actual object, which is not possible for the reason that reference somewhere down means pointer only, basically the address of an object, and client cannot directly hold the address of the object in another process. That is one hurdle. Second is, when client wants to invoke this add method, it needs to pass the value of a and b, which are probably residing here. In client process we would have, let's say, a is equal to 10 and we would have b is equal to 20. So client will have to now give this value of a and b, which is in the memory of the client process, to the server, and the actual object method add would then have to access this data which is here, and that's not possible again. Server cannot access the data in the client process. Client cannot access the reference to the actual object directly. So how can this communication happen? How can the data 10, 20, the value of A and B be passed from client process to server process? Server process can make use of that data and return it back, return the result value which is generated in server process to the client so that client can make use of the return value. This communication we have to understand now. See, basically whether it is COM or RMI or DCOM, all the three are very similar technologies and are used for distributed computing. COM, Component Object Model, given by Microsoft. RMI, Remote Method Invocation, given by Sun Microsystems. And CORBA, Common Object Request Broker Architecture, specification given by OMG, Object Management Group. All the three work on very similar lines. Their top view, the basic architecture of all the three is similar. So let me explain to you how COM works, and not much difference is with RMI and CORBA. So now basically requirement is client should invoke the functionality of the actual object on server. Now a developer who is going to build this actual object, for his actual object is responsible for generating a proxy stub library. A proxy stub library, that will be something like a DLL file. And we already know that DLL files can be loaded in process. That means an exe executing can load the DLL file within its process address space. Exe can pretty well execute any functionality which is there in the DLL. So what we are doing now, for a given actual object, we are building a proxy stub DLL. Let's say the actual object name is demo, then I'll generate a demo proxy stub DLL. That means for different actual objects, we will have different proxy stub library. This library, this DLL file is supposed to contain, as the name implies, proxy and stub, and we share the same with a client application. That means on the client machine we should have a copy of this DLL. On the server machine also we should have a copy of this DLL. Now when the client wants to create the actual object, client will provide a request. Client will submit a request to the underlying COM services. So you have to understand that on the client machine we have to install COM services. On the server machine also we have to install COM services. So our application is going to be built up over a layer of COM now. That means between operating system and our application we have got COM services installed. So client will submit a request to COM services asking for an instance of a remote object. Now the COM services recognizes with the help of something like Windows registry that for this actual object on this machine, this is the proxy stub DLL. All that has to be done in the registry, Windows registry we'll have to do at the time of configuring the client. So COM services have now recognized that this is the proxy stub library which is used for invoking the functionality of server. Thus, COM now loads this library into the process address space of the client and creates the instance of the proxy. Now, client gets actually the pointer to the proxy, but what it actually assumes is client got the pointer to the actual object. So it's just a proxy, the client side representative of the actual object which a client got. So overall situation now is client has a pointer to proxy object and client is assuming that it has got a pointer to the remote object which is in the server process. So client will now make a call to the method which is there in the proxy. But before this, when a proxy object was instantiated in the client, at the same time a stub object will be instantiated in the server process. See, on server also we have a copy of the same DLL. The COM services on the server will be responsible for instantiating a stub and Basically it loads the DLL first and then it instantiates the stub. So in client we have got the proxy, in server we have got the stub, and these two are connected to each other over a socket. Proxy and stub are now connected to each other for communication using a common protocol. Now basically you can see here SUN, RMI, the protocol used is JRMP, OMG, CORBA, the protocol used is IIOP, Internet Interoperable Protocol, and DICOM uses the protocol as Distributed Computing Environment Object Remote Procedure Call, RPC, Object RPC. So this is the protocol which is used. Of course, in case of DICOM we are discussing. So between proxy and stub, the protocol used is DCE RPC. As per this protocol, which is an application layer protocol, the communication is going to happen between the proxy object and the stub object on the network. So how does the whole process begins now? Now client wants to call a method of the remote object. So client actually then calls the method of the proxy. Proxy would then be responsible for serializing, converting all this data 10, 20, and of course the method name, everything. The complete request is serialized, converted to a stream. Serialization means converted to a stream, and that stream over the socket is submitted to stub. Stub deserializes the data. That means complete request is deserialized for creating a copy of A, which is again 10 here, and copy of B, which will be 20. That means whatever is serialized on client is deserialized on server. The state of the client is duplicated on the server. Now on server, these values A and B can be used by the actual object in execution of this method, of course. And as a result, it will provide us some data, which is, let us say, return value, which is equal to 10. Stub then serializes this, return value will be 20. Stub then serializes this value and gives it to proxy. Proxy deserializes and gets here return value as 20, which is then given to the client application. Client application gets the value 20. See, I repeat, client wants to invoke the functionality of the proxy. So client already has a pointer to the proxy. So client, assuming that it is having a pointer to the remote object, will call the method. Proxy will not have actual implementation of the method. The actual implementation is in the actual object. So what proxy will have to do now? Will have to transport the request to the server. And how it is done? The client request is converted to a stream, and based on the protocol which is used for communication between proxy and stub, proxy will serialize and transport that data to stub. Remember, this serialization and transportation is referred as marshalling. So basically, in technical word, we can say that client marshals the request to stub. Stub now receives the request, unmarshals the request, implies receiving the data from the socket stream. It deserializes the complete request to restore the data which is there in the client process as it is on the server process. This data then is given to the actual object. Stub now invokes the method of actual object. They are in same process, so no problem. So stub on behalf of the client will invoke the method on the actual object. Actual object can use the data which is in the same process, give the return value, and this return value is now given back to the stub. Stub serializes the return value, gives it to proxy. Proxy deserializes the return value and gives it to client. So client transparently, without actually knowing that proxy and stub are doing the job, is communicating with the remote object. But yes, there is a proxy, there is a stub which is taking care of all the network communication. Good thing though here is, as a programmer, we do generate proxy stub DLL, but We do not write code for generating proxy stub DLL. Vendors will provide tools for generating this proxy stub DLL. Like Microsoft gives a tool, Sun gives a tool, similarly Corba OMG also gives a tool for generation of the proxy stub DLL on the fly for a given object. So programmer's responsibility is what? Programmer is going to program either the actual object or the client. Not necessarily same programmer should program both. One can develop actual object, the other can develop a client. But what is the client requirement for invoking the functionality on the server? A simple proxy stub DLL. So this is how inter-process communication is taking place between client process and server process with the help of proxy stub. Proxy stub in COM are referred as stub skeleton in Corba and RMI. That means here this is referred as, in case of RMI, this is referred as stub. Just the name is different, and this will be referred as skeleton. So stub, skeleton. That's how the names are different, but there also at high level the basic thing is same. Of course, what is the difference between RMI, Corba and DCOM now? The protocol is different, and hence the proxy of client, if it is in DCOM, server stub must be in DCOM. Only then the protocol is common. In other words, an RMI client cannot communicate with DCOM object, and a DCOM client cannot communicate with an RMI object. In simple words, there is no chance of interoperability between these three technologies. For the simple reason, their protocols are different. So the proxy and stub must synchronize with each other, which is possible only when the protocol is same. So client process, server process should use same technology for communicating, which is really a limitation in today's world, where we want to develop business objects which anybody across the globe over internet can make use of. I develop some business functionality, some peculiar implementation, let us say currency conversion I want to do, and this currency conversion calculator should be used by everybody throughout the world. I just don't want to restrict it to my company, to my applications. How will I do it? If I use DCOM, not necessarily everybody in the world is making use of DCOM. They might use RMI, they might use Corba, they might use probably some third parties. There are many more other distributed technology techniques. So that's not feasible. And what's the bottleneck? The protocol. Yes, one thing though, if Sun says, Microsoft says, Corba says, our protocol can be supported by the other. For example, imagine Sun Microsystem implementing DCE Object RPC in their technology, Microsoft implementing JRMP protocol in their technology, then yes, we can say that the technologies can interoperate, but otherwise no chance. And pretty obvious, Sun will never implement Microsoft protocol in their technology, and Microsoft will never implement Sun technology protocols in their technology. That means interoperability will not happen with RMI, Corba and DCOM. So obviously there is now a need for something which is neutral, something which is not specific to Microsoft or not specific to Sun, and still the communication can happen between client and server. That's where came the specification SOAP. SOAP is a specification where we use XML and HTTP. HTTP we know is by W3C. W3C has a contribution for it. XML is a specification by W3C. SOAP is also a specification by W3C. Simple Object Access Protocol. It's a specification given by W3C for making objects communicate over network, and more precisely internet. So now we are going to develop a web service. Basically now this actual object is going to become a web service, and that web service I can develop in Java, I can develop in .NET, I can develop in any other language, whatever language I prefer. The point is, when the request comes from the client, the request must be as per SOAP format. Our technology is going to receive that SOAP request. Let's say the role of stub now in our case is going to be played by ASP.NET. So ASP.NET will receive a SOAP request, convert to .NET format and give it to the web service which we are writing here in .NET. Web service will execute the request, give the return value back to ASP.NET. ASP.NET will convert this .NET request to SOAP format and give to the client. So what is the requirement on the client as well? Client should understand SOAP response and it should be able to initiate a SOAP request. That means client also should be supporting SOAP. Now, SOAP being a neutral protocol, not by Microsoft, not by Sun, not by IBM, not by Oracle, by W3C, which is a neutral body, all the vendors will not have any problem in providing support for SOAP protocol. So SOAP is a neutral protocol, hence Microsoft provides support for SOAP, Sun provides support for SOAP, all other technology vendors nowadays are providing support for SOAP, and hence if we can develop a web service in .NET, anybody in any language can interoperate with our web service. So what is a web service? As you can read here, a web service is a business object running on a web server. Yeah, we need, in case of ASP.NET, we would need IIS web server for hosting a web service. So it's a business object running on a web server, providing its functionality to any type of client application which supports SOAP. Now when I say here any type of client application, what do I mean? It can be a Windows application, it can be a mobile application, it can be a console based application, it can be a web based application, it can be again another web service, one web service talking to another web service. So client can be any type of web application which is communicating with a remote web service. What is the only requirement on the client? Not necessary again that on the client also we should have .NET. The only requirement which is there on the client is it should have support for SOAP protocol. It may be .NET, it may not be .NET, it might be Unix platform where somebody is using Java for development. Still they can make use of our web service. So in .NET, web services are managed by ASP.NET Framework. Like earlier we have seen in our other course ASP.NET, how ASP.NET can be used for development of web-based applications having web forms. So now we are making use of ASP.NET Framework for development of web service. These web services are mostly used, not necessary always, but are mostly used for developing business to business services. It can be credit card service, it can be something like currency conversion. I told you already. I want to provide some information about my organization to various other associates of mine. I can do it in the form of web service. So it can be any kind of business requirement which I want to provide service over network. I can do it as a web service. And already said, so any kind of application which can be developed in MS.NET can be developed as a client to web service. Now we understood clearly that I'm going to develop a web service in .NET and others in any technology are going to make use of. Imagine now I have developed a web service in VB.NET. Now if I develop a web service in VB.NET, how would somebody consume it? What is that I'll give to them for consuming my web service? Suppose I give them a VB.NET class. See, actually for them to consume my web service, they should know what all are the methods of my service. Business method names, their parameters and return type. Only then they can invoke the functionality. And how would they know this information? Suppose if I give them a VB.NET class, the problem would be they would not be able to interpret the code in VB.NET as they don't know VB.NET. And a class of VB.NET would not be useful to a Java programmer. And even probably let us say to a C# programmer, syntax is not aware of. So providing a VB.NET class to a client for providing information about the service is meaningless. So what is the alternative? What is the best way of providing information about our service to others? WSDL, Web Service Description Language. WSDL is an XML document It's an XML document. So we all know that XML is neutral. So WSDL is an XML document which contains complete information about the web service. It contains information like what all methods a web service has, what all are the parameters of the web methods, what is the return type. I mean, complete information, the URL, the location of the web service, how a binding, the communication can happen between client and service. There are different types of bindings. So what is the type of binding? Every information which is required for a client to invoke the functionality of the service is available in the form of web service. WSDL document, sorry. So WSDL document is what I have to generate for my web service. This WSDL document, the XML based document, I'll share it with my clients who want to develop client application. Now what will they do with this WSDL document? If somebody is a Java programmer, from WSDL document they can generate a Java class which is going to behave like a Java proxy. Somebody is a C# programmer, they can generate C# class. So basically it is like this. WSDL now has become a industry standard. It's neutral. Various vendors have provided utility programs for which WSDL document is the input. What we give as input is a WSDL document, and the utility for that from the WSDL document for a given technology, given language, generates a proxy class. This proxy class can now be used by the client application, and using this proxy class, rest of the communication can happen in the web service environment. So if at all somebody is a Java programmer, from WSDL document, Java class is generated. Somebody is a C# programmer, WSDL document, C# class can be generated. JScript class can be generated. C++ class can be generated. We just need that utility program which would be provided by the vendor of the client technology. And hence web services today, I would say, have made interoperability of communication between client and server possible. As we progress, we would also see what exactly is SOA, service oriented architecture. I can say that service oriented architecture applications can be designed and developed using web services kind of scenario. There is, for the simple reason that client and server are very loosely coupled to each other when the client is making use of a web service. We don't have tight coupling. RMI, CORBA, DCOM, we have very tight coupling. Whatever is the technology used on server, same technology has to be used on client also. But here in web services, the communication is very much vendor independent. Technology vendor independent. We can use simply any technology for development, any technology for client, and hence service oriented architecture found web services as one of the best ways for implementation. Anyhow, we'll discuss more about it as we progress further. In the next video, we are going to see a complete example of how a web service can be developed and how it can be consumed in a Windows and a web kind of application. Thank you.